Okay, so what we're going to be doing is what I call unwrapping the unit circle. And so this is our old friend, the unit circle, right? We know what this is. The coordinate points on the outside give us obviously their XY coordinates, but we know that the X coordinate is the cosine and the Y coordinate is the sine, right? And they're just distances. So if we look at what we're doing, and again, a copy of this is in today's folder, basically, if you read the paragraph there towards the bottom of the screen, then we basically have the unit circle, right? It's got more lines, it's got more kind of spokes, because they call this like a bicycle wheel, a 1-inch bicycle wheel, so it's a very small bicycle, whatever. But essentially, it's a unit circle, right? So I've got like the pi over 6, pi over 4, pi over 3 angles labeled. But if we think about this, right, what we want to do is basically unroll the unit circle. And we want to call the X value the angle of that spoke, of kind of where we are, and the Y value as the vertical distance from the end of the spoke to the X-axis. Okay, so we're going to call this spoke number 0, and obviously because it's 0, the angle is 0 too. By the way, before I go any further, it's important we see the angles we're going to be talking about are exclusively in radians. Okay, we are not going to be talking about degree measurements at all when we're doing the graphing of trait functions. So only in radians. So what I want to do in normal times, if I had a classroom full of you guys, I would have the desks like in groups and have you guys work on this as kind of an exploration. But obviously with sitting in 25 different places around San Antonio, it doesn't work as well. But we can still kind of do this working a little bit together. So if I make a table of values where I'm calling the X, again, X is the angle in radians, and then the Y is the vertical distance from the end of each spoke. Right? And again, these are just off the unit circle values. So when X is 0, obviously the vertical distance to the X-axis at that point is 0. Doesn't take a whole lot to see that. But if you start moving to a different spoke, so like let's either go to pi over 6. Well, we know just from the unit circle that vertical distance is the Y value, and we know the Y value at pi over 6 is 1/2. That was not a very good vertical line. A little better, not much better. So that means that coordinate point here would be when X is pi over 6, then Y, that vertical distance, is going to be 1/2. We can do the same thing as we kind of go to the next spoke. Now, I'm not going to do every single one of these around the whole circle, don't worry, but I do want to do the first quadrant because from there we can start looking at a pattern. So if we see pi over 4, and again, we know off the unit circle, we know that's going to be root 2 over 2. That's about 0.71 if you stick that into a calculator or Desmos. Let me get here, I'm talking about that distance right here. And then if I go to pi over 3, I can measure that distance. And we know at pi over 3, the sine of pi over 3 is root 3 over 2, which is about 0.86. And then something fun happens when we get to pi over 2 up here. Obviously, we know the radius, the length of these spokes is 1. So that means at pi over 2, the value is just 1. That vertical distance is 1. Now, what I'm going to look for a volunteer, either in the chat box or just unmuting yourself and out loud, what would happen? So obviously from 0 to pi over 2, the vertical distance went from 0 to 1. what's going to happen as I come around here? Obviously, this is going to be at pi. What happens to that vertical distance as I go from pi over 2 back down to pi? What happens to that vertical distance?
It's going to become negative 180.
So the angle, and again, remember, no, we're not using degrees, we're using radians. So yeah, so the angle goes from pi over 2 to pi, which is 180. Well, we got to use radians. But what I'm asking is, what happens to these numbers? So
Oh, they're just going to turn negative.
not yet, because remember, it's because we're still going above the y-axis, right? So the distance is still positive. But if it goes from 0 to 1 in the first quadrant, what's going to happen from
1 to 2. So if it's going from 0 to 1 and then 1 to 2.
Not to 2, because again, the biggest it can get is 1, right? Because that's our vertical distance. But as we come around to here, my vertical distance from that point that I'm making right there, that big point, the vertical distance between that point and the x-axis is 0. So it goes from 0 to 1, and then it goes back to 0.
Mm.
You see what I'm saying? And then on the bottom side, now, because now I'm in quadrant 3 and 4, now it's going to go from 0 to -1.
And then back from -1 to 0.
And then from -1 back to 0.
Oh, that's pretty easy. That's not bad.
You see what I'm saying?
Yeah, that's not bad. That's cool.
So here's the whole thing, and I know I just made a mess on that picture. What would that look like if I did that whole pattern like on a plain old XY axis, which I have right here? So notice, even though it has normal numbers, like this right here is pi, so that's half of the first half of the circle. This guy over here is 2 pi. And then half that distance, 1, 2, 3, 4, 5, 6. This is like our pi over 2. 1, 2, 3, 4, 5, 6. This is our 3 pi over 2. So if I just graph the axis points, so again, at 0, it's 0. Pi over 2, it's 1. And then back to 0. And then down to -1. And then back up to 0 where it hits 2 pi. If I just do those points right there, it looks like this. So there's 0. At pi over 2, it's up here at 1. When I hit pi, it goes back to 0. 3 pi over 2, it comes down to -1. And then back up to 0 when it hits 2 pi. And then if you look at the pattern, like in between 0 and 1, like the numbers, like 1/2, 0.7, 0.8, whatever, if you just kind of eyeball those, and I'm not going to graph it specifically, but you start getting an idea of this is what the function looks like. And that is the function of y equals sine x, where the domain value is the angle that you're talking about in radians, and the output, the y value, or the range, is the vertical distance. In other words, the sine value at any given angle. Now, that is a hand-drawn, and it's not the worst thing I've ever seen in my life, but I want to show you a good computer-generated version of this. There's an old saying in education where if a picture is worth 1,000 words, a moving picture is worth even more. So I have a link, and I put the same link in today's folder. So if you go in today's folder where the notes are, you'll see a link that's going to take you to this right here. So what I have here, and when you click on the link, it's going to default to cosine, so I just chose sine. And I also chose here radians, just so, because we got to deal with radians. So here's our graph. Now what I want you to do, as I pull this point on the circle, I want you to watch the red dot on the graph. So as I start going from 0, notice it starts at the origin, where we started, 0, 0. But as I start going up, here is our high point, comes back down to 0, goes down to -1, and then comes back up to 2 pi. Now, the only thing about the graph that I drew on the smartboard and this is the thing to remember, it doesn't stop, right? Because remember our old friend, the coterminal angles? So I can do that same pattern over and over again, but the y values just keep on repeating. I can do this all day long, even though it's way off the screen, right? So we can keep on doing these coterminal angles. And not only can we go coterminal angles in that direction, but I can come back to 0 and I can go in the negative direction. Remember that negative angle is measured clockwise. So if you start here doing a negative angle, it's doing that same exact pattern. And again, I can keep on going coterminal angles as many times as I want to. Okay, so again, there's a link to this in today's folder. You can get in there and kind of play around with it and get hypnotized by watching the dots move and all the stuff like that. So now that we have sine, can we do the same kind of trick for cosine? Well, we can. And in fact, the only thing that changes when we do cosine is instead of, we're going to do the exact same process. We're still going to start at 0 and kind of work our way around the circle. But now, instead of measuring the vertical distance from any spoke, we're going to measure the horizontal distance. So how does that change? Well, now if we start here, obviously my horizontal distance to the y-axis, that distance is 1. As I start going to different spokes, I can measure that distance, and again, these are all just distances on the unit circle. And by the time I get to pi over 2, that distance is 0. And then we start measuring the other distances on the other side. Remember, these distances, kind of like Noah said a second ago, all these distances are negative because they're in quadrant 2. Until we get down to here, and that distance would be at -1. When you get to pi, same thing as we come around here, it'll be 0 here. And then if you keep on coming back around to 2 pi, it'll come back to 1. So what would that look like? Well, same deal, right? We got pi, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, pi over 2, 3 pi over 2, and 2 pi. So now, instead of starting at the origin, now we're starting up here at 1, because that's where that first spoke was, spoke number 0. Then it comes to 0 at pi over 2, and then at -1, and then 3 pi over 2, and then back to 1. And again, it's that repeating, is what we call periodic. It's that periodic function that once you do that one full cycle, it just starts repeating itself. Okay? Again, I wish we had been in person because this is a cool discovery that you can do yourself with like a ruler and a piece of string and stuff like that. But times are what they are, and you know, it is what it is. So again, if you change your link to cosine instead, and you bring the graph up, you see the graph, and you can bring that circle around, you can see how it makes that same pattern. And again, coterminal angles, we can keep on going forever, never, never. We can go in the negative direction, same exact pattern, and all that good stuff like that.
Now, the thing I want you to notice on both of these things, and I'm just gonna kind of switch back and forth a couple of times, each of these things can like be divided into basically 4 sections. If you think of one period, one cycle, you know, there's one section, there's the next section, there's the next section here, and then we're done. When we do start graphing these things, ladies and gentlemen, we're gonna do the exact same thing. We are basically gonna graph 5 points. We're gonna graph the starting point, the maximum, the next middle, the minimum, and then the next middle, and then that's gonna be one complete cycle, and that's all we're gonna have to do. The exact same thing happens on the cosine graph. So the cosine graph, there's still 4 sections, right? But now it starts at the maximum, goes to the middle, minimum, middle, maximum. So every time we graph these things, we're gonna divide it into 4 sections. That's how we're gonna get our points. And then we'll have our graphs. But it's a process that we'll go into starting on Monday. Okay, now for my big finish, let's talk about what happens for tangent. Now for tangent, I'm gonna bring up a different graph. Let's see, I'm gonna bring up this one. Now the only thing about this one, I can show you what tangent looks like on that first graph right here. I don't want to, at least not yet. I want to show you why, and see if we can think about what it's going to look like just based on sine and cosine. So the nice thing about this other graph here is I can show you sine and cosine at the same time, whereas on the other one I can't. So again, I'm going to pull this guy around, and it's going to make myself a nice, I'm going to make it a little darker here. And it's going to make my sine and cosine graph there at the same time. Okay, now keep in mind, my cosine is blue and my sine is red. I'm going to write that over here too. So this is cos, oops. Yeah, so this is cos, and this is sine. Now, think about what that would mean. What would tangent look like? What do we know about tangent? I'm going to do this, and I'll do this, and I'll do it again. First of all, we know that tangent of theta, or x, or whatever, it doesn't matter, is equal to, we know it's sine over cosine. Remember that my tangerine mean? You know tangent equals sine over cosine. Well, that means if sine is equal to 0, so every time that sine equals 0, that means tangent is going to be 0. So anywhere on my red graph of sine, anywhere at 0, tangent is going to go through that exact same spot. It's easy enough. But what happens when cosine equals 0? Let me get a volunteer from Zoomland. If the cosine is equal to 0, what happens then? What happens anytime you divide by 0? It's not 0. You guys, so after class, don't do it right now. After class, go to Google Images, and in the search bar, type in divide by 0 meme, and you will see some funny things. Some of them are not going to be school appropriate. I'm going to warn you right now. But there are some pretty funny memes about dividing by 0. Because you can't.
If you try to divide by 0, it is undefined. So when sine of 0 is 0 on top, that's fine. That's 0. That's why those points kind of are the same thing. But when cosine is 0, like at pi over 2, this is going to be an asymptote. If you remember your algebra days, anytime you divide by 0 or if something's undefined, you get an asymptote, which means the graph is not defined at that spot. Once we know that, so we know our zeros. Oops, and I had one too many asymptotes there. I did that asymptote in the wrong place. Sorry about that. Yeah, literature fun. So once I have my asymptotes, now I can kind of sketch it in because again, I know the asymptote is basically like infinity. And I know here in my first section between the 0 and the first asymptote, it's going to keep on getting bigger and bigger. And then this side's going to kind of come down this way. And then it's going to do the exact same thing. So negative infinity, because notice in this section here, I have a negative divided by a positive. So it's got to be a negative. So negative infinity is going to swoop up, go to 0, and then both things are positive. Because it's two negatives, make a positive. So like this, same pattern, and then the same pattern kind of going on this way. So that is how the tangent function, that's why the tangent function looks the way it does. And now I can get rid of all my messiness and I'll show you the real thing. So now if we go to tangent, you see these are a little bit kind of flatter than I like them. That's why I don't like this graph very much. But again, if you follow the point, there's the asymptote. When it kind of swoops back and forth, that's our asymptote right there. And then it does that same pattern. And again, over and over and over and over and over again. You may also notice that the sine and cosine graphs are basically the same thing. They're just kind of shifted one to the other. They almost overlap, but it's the same kind of repeating pattern. So that is an overview of why the graphs look the way they do of sine and cosine. Let's see, 120, time is 37, got about 15 minutes. The next thing I want to talk about, and I'm going to wait till tomorrow to do this because again, I don't want to get too far ahead of Ms. Bustamante and Dr. G because they're going to lose a day tomorrow from second period for the class ring and graduation stuff presentation you guys will go to. So tomorrow in class, we're going to talk about the domain and range and some actual properties of the sine and cosine function. Not so much tangent. We're going to talk about tangent, but the big point of this is successfully graphing sines and cosines and transformations. So we're going to talk about just the basic properties of our parent functions tomorrow. If you remember parent functions from your Algebra 2 days, we're going to talk about those same attributes for sine and cosine and tangent. And then we're going to just kind of introduce some transformations. And again, Algebra 2 days, what do the different things do? And then bring in some vocabulary that are kind of specific to sine and cosine functions, what are called sinusoidals. And then the real fun starts on Monday.